What's up everybody, welcome to another video, and I hope you're ready to flex those brain muscles. In this video I'm going to do some problems involving ellipses, so graphing ellipses, finding center, vertices, foci, stuff like that. And what I did is I put 4 examples into a worksheet, and the link to that worksheet will be in the description below. So if you want to check that out and follow along, or even better yet, try some of these on your own first, then use this video to check your answers, you can do that. I'll have all the timestamps to each problem in the description below to make it a little easier, and hopefully this video helps you get more comfortable with this material so you can do better on your exam. So before I jump into the first example, I'm going to quickly go over some important information about ellipses, and this is sort of a summary of most of the information that we need to solve these kind of problems. And I'm going to go through it kind of quickly because I'm hoping that most of you all have seen this before in your pre-calc class. Okay, so there are 2 different forms that we see ellipses in. These are sort of our general forms, and the only difference is which term the a squared and the b squared are in, right? In this first general form, our a squared is in the denominator of the x term, and the b squared is in the denominator of the y term, and in the next form those two are switched. Right? So these are the 2 different forms we see these in, and how these forms differ graphically is that this first one has a horizontal major axis. So the major axis is parallel to the x-axis, and the second form has a vertical major axis. So the major axis is parallel to the y-axis. And remember, the major axis is just a line that intersects the center, vertices, and foci, right? All those things lie on this major axis. So how we can kind of, look at an equation of an ellipse and tell whether it has a horizontal or vertical major axis, or at least the way I do it is I just think, well, I know that a is bigger than b. That means that a squared is bigger than b squared. So whichever term has the larger denominator, the variable in that term is going to be the axis that the major axis is parallel to. Let me say that one more time. I know it's kind of a mouthful. Here, the larger denominator is in the x term, and the major axis is parallel to the x-axis, right? Here, the larger denominator is in the y term, and the major axis is parallel to the y-axis. So this is kind of the pattern that I use to be able to just look at the equation of an ellipse and immediately tell whether we're going to have a horizontal or vertical major axis. Hopefully that makes sense. Our center is HK. A represents the distance from the center to the vertices. B, and this is kind of a mouthful as well, but hopefully this will make more sense once we get into some examples. This is the length of a line drawn perpendicular to the major axis from the center to a point on the ellipse. C is the distance from the center to the foci, and then we have this equation that relates A, B, and C. And this is really useful because if we're given an equation and we're trying to graph it, we need to find C, and we can do that by just taking the larger denominator, subtracting the smaller denominator, and then taking the square root of that result, and that's going to be our C. Right? So you can see this equation in different forms. If you add b squared to both sides, you have a squared equals b squared plus c squared. However you want to remember it is fine, as long as it's equivalent to this relationship between a, b, and c. So I think that's all I have to say about just the general information about this. Let's see if we can go ahead and put this into practice in the first example. Alright, so given this equation of an ellipse, we're going to find the center, vertices, foci, and sketch a graph. And the first thing I like to do is just see what information I can gather about this ellipse by just looking at this equation. And the first thing that stands out to me is that the larger denominator is in the y term, right? That means that our major axis is going to be parallel to the y-axis, which means we have a vertical. So let me write this in black actually. Vertical major axis. I'll abbreviate that as MA. So that's one thing we can identify. What else? Well, since this is the larger denominator, that tells us that our 9 is a squared, right? So a squared equals 9. And if we want to find a, we can just square root both sides, and that gives us a equals 3. And you can usually do this in your head, right? Square root of 9 is 3. Just like this 4 is our b squared. So that means that b equals 2. We can just do that in our head, right? I just figured I'd write out the first 1 since this is our first example. And now we can use that equation that relates a, b, and c. We know that a squared, which is 9, minus b squared, which is 4, equals c squared. And we're trying to solve for c. So we can just simplify the left-hand side, then square root both sides, and we get c equals the square root of 5. Okay, so let's see if we can make some room, clean this up a little bit. I'm actually going to put the a over here. And now what else can we find by just looking at this equation? We can find the center, right? Because our center is hk, and in this case h is 3 and k is -1, because we could think of this as y minus 1 squared. So our center is at 3, -1. And now you could write out the vertices and foci if you know how to find those given this information. But what I actually like to do is go to the graph from here. I get all the information I can get by just looking at the equation of the ellipse, and then I start sketching the graph, and then I finish getting the rest of the information from that sketch, and you'll see what I mean by doing this. So first I'm going to plot the center, 1, 2, 3, -1, and I'm going to do this in blue because it's not technically a point on the ellipse. I'll do it in blue. So this is our center, and remember, we have a vertical major axis. That means our vertices and foci are going to lie on this vertical dotted line, right? So if A represents the distance from the center to the vertices, that means from this center to each vertex, I go a distance of 3. So if I go 3 up vertically, I get up to this point, giving me a vertex there. And then if I go down vertically, I get down to this point. So these are my vertices. And I like to do this because I like to visually see my vertices. It's a lot easier to write them out, in my opinion, if I do it this way. So what are my two vertices? Well, the first one is 3, 2. And the second one is 3, -4. Okay, so I have my two vertices. And from here, what do I need to find? Foci, and then I need to finish the sketch of the graph, and we'll be done. So how can I find my foci? Well, I know that C is the distance from the center to each focus. And since C is square root of 5, I can just go up square root of 5 from the center and down square root of 5 from the center, right? So square root of 5, let's see, square root of 4 is 2. So square root of 5 is slightly bigger than 2. So it's somewhere around here. And if you want to use a calculator and punch it in, you can. I'm not going to do that. I like to keep it in exact form. And if you keep it in exact form, what you end up with is some kind of ugly looking points, I guess. But you get 3, -1 plus root 5, comma, and then the other foci is 3, -1 minus root 5. So you could get an approximation by punching this in a calculator. I'm going to leave it like that. And now the last thing I need to do is just finish the sketch of my graph. So what does the value b tell us? Well, that tells us that if I draw a line perpendicular to the major axis from the center, then if I go a distance of b, which is 2, I intersect a point on the ellipse, right? So that tells me that these are both points on the ellipse. So it sort of gives us a sense of like width, I guess you could think of it, but it helps us complete our sketch. So in this case, our ellipse looks something like this, and I'm not good at drawing these shapes, just warning you. Something like this. Mine usually look like footballs. And that's going to finish the sketch of this graph. I think that's about as good as it's going to get. We have all the information we were asked to get: center, vertices, foci. We have them all labeled off to the side here, so there's no need to really label any points. And we're good to go. Let's move on to the next example. So with this example, the equation isn't in the form we want it to be in. So the first thing we have to do is manipulate this equation and get it into the form we want it to be in. And doing that involves doing something called completing the square. And there's a lot of different ways to do this. I'm going to show the way that I like to do it. And what I like to do is group the x terms together and the y terms together on the left-hand side and move the constant to the right-hand side. So that's what I'm going to go ahead and do. So I have x squared plus 3y squared, and these are actually already kind of nicely grouped together. I have my y terms next to each other, equals, so all I have to do really is subtract 9 from both sides of this equation. Now, we want to represent both x and y as a binomial squared. But notice that we only have x squared, we don't have an x term. So we actually don't have to worry about trying to complete the square with x squared, because we could think of this as x minus 0 squared, right? So one of the points of our center, the x coordinate, is going to be 0, in other words, right? So we can leave that alone. So we really only have to complete the square with these y terms. And what we first have to do is factor this 3 out in front, because this completing the square process only works if the coefficient for the squared term is 1. So we always have to factor out whatever the coefficient to our squared term is. We have to factor that out in front. So what I have left is y squared minus 4y. And I'm going to leave this blank in here, plus something, because I want to add something in there to get it to be a perfect square trinomial, so I can factor it into a binomial squared, right? And this is the process. Remember, take half of the coefficient of the y variable, right? So half of -4 is -2. I square that, so that's 4. And that's what I add inside here. That's going to make this a perfect square trinomial. Now I have to balance both sides of the equation, right? So that means I have to add 4 to this side as well, but be very careful. Notice the mistake I'm making here by adding 4, right? Because although I added 4 to this left-hand side of the equation, I did that inside of a parentheses that's being multiplied by 3. So really I changed the left-hand side of the equation by 12, right? I added 12 to the left-hand side of the equation. So I have to be careful. That's the most common mistake I see people make. You have to make sure that when you factor out a number, you have to make sure that when you add inside here, you balance both sides of the equation in the correct way, right? So now I can complete this process. I have x squared plus 3 times, let's see, this should be y minus 2 squared. And if I FOIL that out, I should get just what I had above. And I can simplify this right-hand side to be 3. And now all I have to do is divide both sides by 3. We always divide by this constant on the right side because we want this to be 1, right? So if I divide both sides by 3, what I get is x squared over 3 plus y minus 2 squared over 1 equals 1, and this is the form that I want it to be in, right? Now I have it exactly how I want it, to where I can gather information and sketch the graph and do all of that. So let's go and erase and make some room. Hopefully that process made sense. It may take doing a couple more examples to fully get that down. Let's go and move this up here. So we've rewritten the equation in the form we want it to be in, and now we can identify whether our major axis is vertical or horizontal and start getting information. So in this case, the bigger denominator is in the x term. So in this case, we're actually going to have a horizontal major axis. So horizontal major axis. That also means that our a squared is 3. So that means that our a is the square root of 3. And I'll make a little bit of room here because I'm also going to write b is the square root of 1, which is just 1. Right? And now I can find c. What does c equal? Well, I can take a squared, that's 3. I can subtract b squared, that's 1. And that's going to equal c squared. So that means c squared equals 2. And that means c equals the square root of 2. Okay? So hopefully that made sense how I got all those things. So c equals square root of 2. I'll write that up there. My 2's kind of look like z's. Let's see, 2. Is that a little better? Now I can erase this. What else can we find? The center. The center. Well, remember I said we can think of this as x minus 0 squared. So that means the x coordinate of my center is 0. And the y coordinate is 2. So we found the center, and I think that's all the information we need to start sketching this graph and seeing if we can finish off finding the vertices and foci. So I'll draw my x and y axis here. My center, x equals 0, y equals 2, so 1, 2, and I'll do it in blue again. And I remember this time my major axis is horizontal, so all the points, right? Well, not all the points, but the vertices and foci are going to lie on this dotted line. So in the last example, all of the x coordinates of the center, vertices, and foci were the same. They were all 3. And in this example, all of the y coordinates are going to be the same. They're all going to be 2. So that's another way you can kind of do this. Instead of going straight to the graph, you can notice that pattern, and you can get the foci and vertices before drawing the graph. If you want to do it in the other order, that's fine. So let's see, a is square root of 3. That's the distance from the center to the vertices. So if I go a distance of root 3 to the right, that's going to give me 1 vertex, and then I can do the same to the left. So I'll label this as root 3. This is negative root 3. These numbers are a little bit ugly, so I'm just doing the best I can here. So that means that the vertices are, well, remember, the y coordinates are 2 for both these vertices. So that means I just have negative root 3, 2, and root 3, 2. And you could get an approximation by punching that in a calculator if you want. Now I just need to find my foci, and I'll do this in red. Remember, the distance from the center to the foci is c, so that's root 2. So that's somewhere around here. Those are root 2. So in a similar way that I found my vertices, I can keep my y value the same, and this x coordinate here is negative root 2. This x coordinate here is positive root 2, right? So my 2 foci are going to be negative root 2, 2, and root 2, 2. Hopefully that makes sense. The last thing I have to do is use my value for b to get a couple of points on the ellipse. That's going to be this point and this point. Remember, I draw a line perpendicular to the major axis, right? And that's going to intersect points on the ellipse. So both of these are points on the ellipse, and now I'm realizing that I drew this a little bit small. I apologize. But I should have all the information I need. Let's see, center, vertices, foci. Yep, so now I can complete the sketch of this ellipse. They always look like footballs. I'm telling you, when I draw them, it always looks like a football. But that looks like the complete sketch to me. That's about as good as it's going to get. Hopefully that process made sense. Let's move on to the next example. So for these next 2 examples, we're sort of going the opposite direction. Instead of being given an equation and gathering information from that equation and sketching a graph, we're being given information, and we have to find the equation and sketch a graph. So what I like to do is take this information and plot these points and just go straight to the graph. And I think you'll see why I like to do this once I do it. But I'm going to draw my x and y axis here. And I know that my center is 2, negative 2. So I'm going to plot that first. 2, negative 2, and I'll do it in blue. So this is my center. I have a vertex at 7, negative 2. So 3, 4, 5, 6, 7, negative 2. So this is a vertex here. And then I have a focus at 4, negative 2. That's here. So now I can tell that all of these fall on some horizontal line. That means I have a horizontal major axis, right? So that's going to help me when I get my equation, because it's going to tell me that my a squared is going to be in the x term, right? Under the x, and the b squared is going to be under the y. So I'll just make note of that. Horizontal major axis. And I can also find a and c from this information, because a is the distance from the center to each vertex. And in that case, it's what? 5, right? And c is the distance from the center to the foci, which is 2. And I'm just looking at this. This distance is 5. This distance is 2, right? And from here, what I can do is actually copy this in the other direction. So that means that this is a focus as well, right? And that means I can go a distance of 5 to the left. Let's see, 1, 2, 3, 4, 5, and that's going to be a vertex, right? So now I'm getting closer to finishing my graph. Now what I can do is find a squared and c squared pretty easily. I can just square both of these. So this gives me a squared equals 25. This gives me c squared equals 4. And now I can find b squared because I'm going to need b to finish the sketch of my graph, and I'm going to need b squared because that's going to be in my equation, right? And I know that a squared, that's 25, minus b squared equals c squared. So now I can solve for b. So I'm going to add b squared to both sides of this equation and subtract 4 from both sides in the same step, but I think y'all can handle it. Hopefully you see how I get this. 21 equals b squared. So I did 2 steps at once. Now I can square root both sides, and I get b equals the square root of 21, which is going to help me finish my graph. And I get b squared equals 21, which I'm going to need in my equation, right? So I know that the square root of 21, let's see, that's somewhere between 4 and 5, because the square root of 16 is 4, and the square root of 25 is 5. So somewhere between 4 and 5. And since my major axis is horizontal, drawing a line perpendicular will be vertical. So I'm going to go up from the center a distance of root 21. So let's see, 1, 2, 3, 4, 5. So somewhere between those 2 points, 2, 3, 4, 5, somewhere between those 2 points. So this is a point on my ellipse. This is a point on my ellipse. And now I can actually finish sketching the graph of this and then write out the equation. So let's see. This is actually a pretty wide ellipse. When the values of a squared and b squared are close together, like they are in this case, the ellipse looks more and more like a circle the closer those two values get together. So this is the final graph of my ellipse. That's about as good as it's going to get from me. Let's see if we can write out the equation and then move on to the last example. So what do I need here for the equation? I need a squared and b squared. So I'm going to erase that. I'll erase this. I'll erase that. I'll move this up here. And I also need the center, which I was given, right? The fact that the major axis is horizontal, I'm going to use all this information because what I know based on the center is that we have x minus 2 squared, and we have y minus negative 2, so plus 2 squared. Okay, let me see. I might need a little bit more room here. We always have equals 1. That's always on the right-hand side, right? Now I just need to figure out what's in these denominators, and this is where the horizontal major axis comes into play and our a squared and b squared, right? Since our major axis is horizontal, the larger number, so a squared, is going to be in the x term. So in this denominator I will have 25, and in this denominator I'll have 21, and that's all there is to it. There's probably different ways to approach these kinds of problems. If you did it a different way, that's totally fine, as long as you got this equation and this graph. Hopefully your graph looks a little better than mine, but that's all for this example. We'll do one more and then finish up the video there. So with this last example, we're given both vertices and a focus. So let's see if we can take this information and sketch a graph of this ellipse as well as come up with the equation. So I'm going to start out the first way that we did in the last example, which is just by plotting the points that were given. As you can see, I already have an x and y axis here. So I'm just going to start by plotting the vertices. So I'm going to go 1, 2, 3, 4, and then up by 3. So I have a vertex right here at 4, 3. And then I have another vertex all the way up at 4, 9. So 3, 4, 5, 6, 7, 8, 9, all the way up at the top here. And then I have a focus at 4, 8. So I'll do this in red. There's a focus. And what I want to point out is with ellipses, we have this symmetry, right? The distance between this vertex and this focus is 1. That's going to be the same down here with this vertex and the focus down here. So I can actually go ahead and plot this point here. That distance is 1. And similarly, with our center is always halfway between the two vertices, right? Because the distance from the center to this vertex is the same as the distance from the center to this vertex. So halfway between the two vertices, well, let's see, the total distance between the two vertices is 6, so halfway between would be a distance of 3 from either one, right? So halfway between right there, which gives us the point, our center is the point 4, 6. What else can we notice? We have a vertical major axis. So both of these things will come into play when we're writing out our equation. We'll use both of these pieces of information. We'll also need to know A, which is the distance from the center to the vertices. That's 3. And we already know C is the distance from the center to each focus. That's 2. So now we just need to find B, and that will allow us to finish our graph. And then when we have B squared, we can write out our equation. And we can find B by taking A squared, that's 9, minus B squared equals C squared, that's 4. And now by adding B squared to both sides of this equation and subtracting 4 from both sides of this equation, I get B squared equals 5. So I did 2 steps at once, but hopefully that makes sense. And now I just square root both sides to get B equals the square root of 5. So I have my B, which is going to help me finish sketching this graph, and I have B squared, which I'm going to use in my equation that I write. So let's first finish the sketch of this graph. So square root of 5 is a little bit bigger than 2 because the square root of 4 is 2. So I'm just going to go out a little bit further than 2 and say that's good enough for a rough sketch of this graph. So a little bit further than 2, something like that. And now let's see if I can draw a decent looking ellipse. Here we go. Alright, not so bad. That might be the best one yet, by my standards at least. So we have our sketch, and now we just need to find the equation, and for that we need A squared, which we can actually just square both sides of this, right? If A is 3, then A squared is 9. That's what we need for our equation. And then we also need B squared, which we already found. So we're done with all this information. We just need A squared and B squared. We already have the center and a vertical major axis. That's going to help us out as well. So let's see, can we write out our equation? Well, we're going to have x minus 4 squared plus, and we're going to have y minus 6. This is just coming from the center, right? 1 is always on the right-hand side. Now I know that in one of these denominators I'll have 9, and in the other I'll have 5. And because we have a vertical major axis, that tells me that the larger number, so 9, is going to go in the y term. So under that y in the denominator is going to be 9, and over here we're going to have 5. And that's the equation and a rough sketch of the graph, and hopefully this video helped. If you do this process differently than me, that's perfectly okay as long as you get to the same answer. And sorry my graphs don't look so good. I'm definitely not an artist, so hopefully your graphs look a little bit better than mine, but hopefully that didn't throw you off too much. Thanks for watching. If you have any questions, leave them below. I'll answer all the questions, and keep flexing those brain muscles. I'll see y'all later.